Hi guys, welcome to Physics 1A or Engineering Science, whichever one you're enrolled in. They're very similar. There's going to be some different tutorials, but generally the same lectures will be for both of those two courses. I'm Dr. Adam Palmer. I'm the course convener. I'm also a lecturer, your main lecturer for this course. I'm the go-to guy. If you've got any problems with the course, any problems with the material, or just any problems in general with university life, come and have a chat to me. My door is always open, and that door is in G39 3.46, the engineering building. So if you come along, my door's open, just walk right in and introduce yourself and say g'day. If my door's closed, just leave me an email and we can arrange a time to meet. That's my email address subsequently underneath there. Okay, so I'm really keen to get going with you guys. I really love physics and I really love maths, and I just want to show all of you how important it is to your degree and your career. So I want you to start thinking not of yourself as a student. I want to start you thinking of yourself as a professional, and you're now learning how to be an engineer or an aviator or a scientist. Okay, so step into my course and start thinking of yourself as a young professional, not a student. Okay, we'll start off with that. That's the first thing I want you to know. Okay, and I'm going to treat you like that. Great. So before we get started, I'd like to acknowledge the people of country. So Griffith University acknowledges the people, the traditional custodians of the land on which the university sits. The Gold Coast campus is situated on the land of the Yugambeh Kombumerri people. The university pays respect to their elders and all elders, past and present, and extends that respect to other Aboriginal and Torres Strait Islander peoples. And respect it to all people, really. That's what it's about, respecting people. And I don't really care who you are. Show me respect and I'll show you respect. That's the way it works. So let me just introduce myself a little bit further. I'm not just your lecturer. I do other things around the university. I'm actually a physicist by trade. I do physics, which means that I'm pretty well qualified to teach you undergraduate physics. So this is me in my sort of natural environment. That's my laser there. I basically take that laser, and it's so powerful I can zap things with it and blow electrons off them and see what happens. So that's basically my fun job. It's basically like a bunch of Lego that I can play around with and zap things with. So my job is not really a job. I really like what I do. So that's my laser system. I can do all sorts of cool stuff with that laser system. If you want to know more about that, come and have a chat to me about it. It's pretty fun. This is me in my other incarnation, defying gravity and defying the laws of physics by climbing. I'm generally a climber. So physics, where does it start? Well, it starts from the very big things. This is a picture of a quasar, all these particles swimming around in a quasar. So it's relevant to someone doing that kind of thing, but it's also relevant to very small things, so atoms. So we can go from the very large scale right down to atoms. Now engineering, somewhere in between. You're interested in materials, what they're made of. Well, they're made of atoms. But you're interested in, what they're made of and how the things that they're made of give them the structure that they have. If you're a scientist, you're very much interested in things like this video here, which is the ability to place single atoms and manipulate them around. This is the sort of thing that I'm very interested in. So this is a little movie which is using some technology to move single atoms around and make a movie out of it. It doesn't really mean anything, but the technology behind this is based in physics. And most of the technology that you use is based in physics. So your mobile phone, how many of you know how that works? Okay, there's probably a lot of you, but the technology behind that is just amazing. So technology is underpinned by mathematics and physics, and so is engineering. Okay, don't tell me that there's no physics involved in building a bridge, or I'll never walk across your bridge ever. Don't tell me there's no physics involved in flying your aeroplane, or I'll never get on your plane, okay? And if you don't understand physics and you're doing science, then you're not understanding the full picture, okay? So it's very, very important. And I've left a little thing for you to look at in the course the course page that says, why do you think physics is important to what you do? Okay, so another thing that I do is surfing. This isn't me. I'd have brown trousers at that point. I generally surf anything 3 feet and under and glassy on my 12-foot board because I'm an old man. So this guy is surfing in Chopu. Now there's all sorts of stuff going on here. You're going to learn about electromagnetism and mechanics in this course. So there's all sorts of stuff going on here. There's mechanics, there's waves, there's electromagnetism, making the signals in his brain to make him think, I can surf big waves. So electromagnetism and mechanics are the fundamentals of reality. Okay, so you learn those things first, and you can go on to more difficult concepts. So I find this quite amazing. I can watch that all day because this guy's about to eat it really badly. Yes, there he goes. It gets swallowed up. Great. Excellent. So this is another video I like to show, and this is the image from the space station, the International Space Station, orbiting the Earth. And you can see electromagnetism happening all over the place. There's the Aurora Borealis you see there. There's the lights coming from the technology that we've invented. And the technology to even put something in space like that we can get this image is just outrageous. And it's based in physics, then engineering. So I'll just let you have a look at that video for a little while. Okay. So hopefully I've got through to you that it's super important, physics, to the way our world runs, and actually the underpinning of the universe we live in. So again, I'll just show you my teaching team. There's myself with a stupid grin on my face. I'm your lecturer and convener. There's my details. Any questions regarding the course administration, the lectures, come and talk to me. I have a guy, very, very competent guy called Steve Jones, who will be doing your tutes. He's a very experienced, and I trust him to do the best job for your tutes. There'll be other tutors in there, but I would say he's your head tutor. This is William Wallace. He is, maybe doing a small amount of lecturing from me. He's a tutor. He's also a lab demonstrator. This is also him in another, looking very intelligent there. I assure you he is quite intelligent. And there's also Mr. Valdis Blooms, who will be a demonstrator for you. There might be others that we bring in along the way to help you, but having a competent, strong teaching team is really important, and I think that's going to be very advantageous to you. But come to me with any problems with the course. I welcome you to the course. Make sure you go and have a look at the Learning at Griffith website to see all of the stuff that we already have up for you there. But there will be another set of slides that I'm going to put up for you, and another talk for you that will guide you through all of your assessment, what's required of you inside those sessions.